Okay, when working with the 4 basic exponent rules, they're mostly shortcuts for working with just exponents in general. So for example, if we want to multiply 2 bases together, as long as the bases are the same, we just add up their exponents. That's a short example for, say we had x squared and we wanted to multiply it by x to the 3rd. We would get x to the 5th because x squared would mean x times x to the 3rd would mean x times x, and all together, of course, that's x to the 5th. So we learn that by working through it, and then we take the shortcut of just adding. So for example, x squared times x to the 7th, we would know that, oh, okay, that would mean we'd have 9 x's multiplied together. Quotient rule is for dividing. The shortened version is that I have to subtract the exponents. Of course, this only works if my bases are the same, because this is also a shortcut. Say I had x to the 3rd and I wanted to divide by x squared, just keeping it small. That would mean I'd have 3 x's multiplied together on the top and 2 x's multiplied together in the denominator. And then x divided by itself would divide out, x divided by itself would divide out, and I'd be left with x, or x to the 1st. 3 minus 2 would also give me that x to the 1st. So again, the subtraction is just a shortcut. So for example, if I have something like x to the 10th divided by x to the 4th, I can know that 4 pairs of x's would cross out. I can just subtract these and get x to the 6th without having to show the work. Okay, 2 others that you may remember. The power rule, also known as power to a power rule. Knowing that any exponent outside of the parentheses applies to the one that's on the inside of the parenthesis. This in rule form would look like something like this. X to the m with the n on the outside would equal x to the m multiplied by n. We multiply our exponents together. The reason for that, let me use my favorite x squared and a 3 here. If I have x squared to the 3rd, that would mean I would have x squared times itself 3 times. And then because of the product rule, I would add my exponents together, so 2 plus 2 plus 2 equals x to the 6th. But once I know this shortcut rule here, I can just multiply my exponents together and get right over there to that 6. This rule becomes more complicated when there are numbers inside, because it's easy to forget that that 2 has an exponent. That 2 has an invisible 1 exponent on it. So not only do I multiply the 3 and the 4, that's easy to remember, but I have to remember to multiply the 4 and the 1. So this becomes 2 to the 4th and x to the 12th. And then I can evaluate 2 times 2 times 2 times 2, 2 to the 4th, and get 16. So this would be 16 x to the 12th. Okay. The 0 exponent. Anything to the 0 power always equals 1. This one is its own rule. It's not really a good shortcut. It's just anything to the 0 power cancels out the base and it equals 1. Alright, so let's try these by themselves and slightly mixed together for a few examples. Simplify the following. Okay, these are very basic. I would expect that you could have all come into Algebra 2 knowing these. Oh, okay, power rule. I'm going to multiply 3 times 5, so x to the 15th. Division, so quotient rule, I'm going to subtract. 14 subtract 9 is 5. And multiplying, bases are the same, so I'm going to add. So 9 plus 4, 13. Okay. What if they're not quite so basic? Okay. If there's more than one thing in that parenthesis, remember to multiply all the exponents. So x to the 15th, y to the 6th. People hate these because of the fraction. Work with the big numbers, the coefficients together. See if you can simplify 12 divided by 3. Oh yes, 12 divided by 3 is 4, so go ahead and do it. If it's a fraction that doesn't simplify, you can use or doesn't divide, you can use your calculator to simplify it. And then here, x's, so we're subtracting exponents, so x to the 3rd. This one looks all sorts of crazy and people's eyes start glazing over, but it's not. Just break it down. 4 over 8 is a fraction that simplifies, right? 1/2. You can use your calculator to simplify the way we did in the probability unit. X's go with x's. Remember, there's an invisible 1 whenever you can't see the exponent. So 2 subtract 1 would be 1. The bigger number was on the top up here, so we're going to write that up on the top in the numerator. And then y goes with y, so we're going to subtract the 8 and the 5. So again, bigger number was on top, so answer goes on top. Y to the 3rd. You could write that over without the invisible 1 here or here. You could write x y cubed divided by 2 if you prefer. Okay. The next one's illustrate what to do with these big numbers. Again, that becomes the hard part. This is a multiplication problem, so coefficients multiply like normal. So 3 times 4 makes 12. And then your exponents add. So 10 plus 6 makes 16. This, people get confused with these parentheses. This also just means multiply. So don't use the power rule, just multiply. So big numbers multiply, -6. X's go with x's, y's go with y's. So x to the 5th times another x to the 5th. 5 plus 5 makes 10. 2 plus 2 makes 4. Okay, so work with those big numbers as usual. Alright, bottom row, as hard as they're going to get in this first video. Combining a few rules. This one, here, there's an exponent outside of the parentheses. This is when I know I'm supposed to multiply my exponents together. Do not forget that this 3 has an exponent of 1 on it. So 4 times 1 is going to become a 4th power. 3 to the 4th power, x to the 8th power. For now, we're just copying over the 6x cubed. I can see that my exponent rule needs to get used here. I'm dividing, so I'm going to subtract. And I need to figure out what 3 to the 4th is. If you type that into your calculator, you're going to figure that's 81. So I'm going to have 81. 8 minus 3 is 5, so x to the 5th over 6. And then I'm going to see if 81 and 6 simplify in my calculator using my simplifying skills from my probability chapter. They can both divide by 3, so I would be at 27 and 2. 27 halves. Okay, I think that was the most difficult one we have. I have this one on here to remind you that everything in the parentheses will receive this 7 exponent on the outside, even if it's a fraction. This 7 is going to multiply by every exponent in the numerator and the denominator. So this would be 7 times 3 is 21, and 7 times 4 is 28. Please be aware that you cannot subtract the exponents because the bases are different. So this is the end of the problem. And this next one illustrates that same thing again. Everything in the parentheses will receive the exponent 3. Remember, there's an invisible 1 on the exponent on the 2 and on the 1. So multiply, multiply, multiply. So 2 to the 3rd, x to the 3rd, y to the 6th. 2 to the 3rd in a calculator or your brain equals 8. The x to the third and the y to the sixth do not subtract because they are different bases. All right, ask follow-up questions as needed.